Number 9, a particle starts at x equals 0 and moves along the x-axis with velocity 4x minus t when t is greater than 0. Where is the particle at t equals 7? So where is the particle at t equals 7 means I need to find the area under this curve to see total distance traveled. So if we graph, this is what my velocity would look like. So I'm trying to find the area under the curve from 0 to 7. So another way I can do it is find the integral from 0 to 7 to find where the particle is. It doesn't ask the total distance traveled, it just asks where is the particle. So let's do it with the integrals. So the antiderivative of 4x would be 4x squared divided by 2. The antiderivative of 3 would be 3x, and I'm going from 0 to 7. So I'm going to substitute the 7. And if I substitute the 0, it's just going to give me 0. So I'm going to have 4 times 49 divided by 2 minus 21. And that would be 77. So where is the particle at t equals 7? The particle is 77 units to the right of where it started. Number 10 is very similar to number 4. You're just going to have to use the chain rule. Number 11, we're going to evaluate the integral from negative 3 to 3 of 9 minus square root of 9 minus x squared. So what you need to do is you need to graph it first to see what this is going to look like. This is a semicircle with radius 3, and the negative means that I want the lower part of the circle. The 9 means that I'm going to move it up 9 units. So the circle centered at 0, 0 with radius 3. Okay, it will look like this. And it's negative, so I want the bottom part of the circle. The 9 means that I'm going to move it up 9. So instead of the center being at 0, it's going to be at 9. So I moved everything 9, including these points. So this is what I'm going to look like. I need to find the area under the curve from negative 3 to 3. So remember, to find the area, you start at the x-axis, go up till you touch the graph. Go at the x-axis, go up till you touch the graph. Let me erase this so we don't get confused. So my area under the curve is this. So what I'm going to have to do is I'm going to find the area of this rectangle, and then I'm going to subtract this half circle to give me the area that I need. So the area of this rectangle is going to be the base is 6, right? I have 3 here, 3 here. So since we move the graph up, remember how my center was at 9? So that means that the height of the rectangle is also going to be 9. So the area of the rectangle is 54. The area of the circle is pi r squared, and we're dividing it by 2. So it's going to be pi times 3 squared divided by 2. So we're going to subtract that, 9 pi divided by 2. And that would be my area of under the curve. So it's the big rectangle subtract the circle. Number 12 says, a rate of which water flows out of a pipe is given by a differentiable function r of time t. The table below records the rate of 4 hours intervals for a 24-hour period. Use the right rectangular approximation method with 6 subdivision. That means you're going to have 6 rectangles of equal length to approximate the square root, the integral from 0 to 24 of rt dt, and display the meaning in the answers in terms of water flow. So what you're going to do is just, easiest thing to do is sketch it so you can kind of know what it's going to look like. When x is 0, y is 9.6. When x is 4, we're at 10.3. So this is what my sketch would look like. So what we're going to use right rectangular. So that means that the right is going to touch the graph. So this means find the area under the curve from 0 to 24. So the area of my first rectangle, each of them have a base of 4. Okay, so we don't have to worry about that. So what I'm going to do is I'm just going to multiply the 4 at the end, because it's base times height, and everybody's base is 4. So the height of the first rectangle is 10.3, the height of the second, 10.9, the third, okay, so the first rectangle is 10.3, second one is 10.9, 11.11, third one, fourth one 10.9, the fifth one 10.5, and the sixth one is 9.6. Remember, each of them have a base of 4. So you're just kind of multiplying each one by 4, or you can factor out a 4. So if you add all of this up, you should get 253.2. So then the second question asks, explain the meaning in your answers in terms of the water flow. So since this is gallons per hour, remember when we're usually doing this, we were doing with velocity, especially on your project, you graph velocity versus time or velocities per hour, miles per hour, and you always got miles, which is total distance traveled. So in this one, since you have gallons per hour, you're going to have 253.2 gallons. So what this means is that in a 24-hour period, right, from 0 to 24, in a 24-hour period, 253.2 gallons flowed out of the pipe. So that's the meaning of it. In a 24-hour period, 253.2 gallons flowed out of the pipe. Number 13, a particle moves along the coordinate axis. Its position at time t is the integral from 0 to t of v of x, where v is the function whose graph is shown below. So we're given the graph of the velocity, so we know the graph of the derivative. A says, where is the particle at t equals 0? So this is my position. So s of 0 is going to be from 0 to 0. So my velocity, I'm not going anywhere, or my position would be at 0. Part B says, where is the particle when t is 3? So I'm going from 0 to 3. So where am I when t is 3? That means find the total distance under the curve from 0 to 3. Remember, anything below the x-axis is negative. Anything above the x-axis is positive. So this is a triangle with base 2. The height is also 2, divided by 2, and it's going to be negative because it's below the x-axis. The second is also a triangle with base and height of 1, divided by 2. So I'm at negative 1 and 1/2. So that means I'm 1.5 units to the left. Part C is what is the particle's velocity at t equals 4? So you kind of have to be careful because part C is a trick question. It's where's the particle's velocity? Not where is its position, but what is its velocity? So remember, we're looking at the graph of the velocity. So at t equals 4, my velocity is 3. So when t equals 4, my velocity is 3. So it would be 3 feet per second. Number 14 says a zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors deposited entries in a special box between noon and 8 p.m. The numbers of entries per hour deposited in the box is shown below. Use left Riemann sum with 4 subintervals to approximate the integral from 0 to 8 and explain the meaning of 0 to 8 in the context of this problem. So we're going to use left Riemann sum with 4 subintervals. That means we're going to use 4 rectangles to approximate the area under the curve. So again, best way to do this is sketch your graph. It doesn't have to be exact. It just kind of helps you picture what the graph is going to look like. So we're going to use left rectangular approximation. So that means that the left side is going to touch the graph. So one of the things that you're going to notice is that the bases are not the same. So I'm not going to be able to multiply it like I did in number 12 where my bases are the same, because the base of rectangle 1 is 1, the base of rectangle 2 is 2, the base of rectangle 3 is 1, and the base of rectangle 4 is 3. So I'm not going to be able to use that shortcut. So I'm going to have to use the base times the height for each individual one. So the first rectangle, the base is 1 and the height is 10 because the left side's touching. The left side's touching. Second one, the height is 30 and the base is 2. For For the third one, the height is 34 and the base is 1. And then the last one, the base is 21 and the height is, sorry, the base is 3 and the height is 21. So that should give you 167. So what does 167 mean in the contents of the problem? So notice that we graph entries per hour. So that means that we have 167 entries. So it's kind of the same thing as, remember when we were graphing velocity, we graph miles per hour, and we would get just miles. The hours will cancel out because we're multiplying miles per hour times the time. So same thing here. Since it's entries per hour, we're just going to get 167 entries. So in the context of this problem, since everything's above the x-axis, is total entries. So in 8 hours, from 1 to 8 hours, 167 entries were deposited. So we had 167 entries deposited into the box.